Okay, can we start? Okay. Uh, okay. So there are keywords here. This one is actually a three-phase. Okay, three-phase, 30 kilometers. So this is the short line, and this one 500 kilowatt. So 500 kilowatt. So this is actually P three-phase, which is 500 kilowatt. Okay. So the first one is to find what is the current. Okay, so this is a 500 kilowatt. So you can use okay. So and then one more thing is this one. The load voltage is given 10 kilowatt, but it is not mentioned whether it is phase voltage or line voltage. Okay, so actually this please be noted that assumption has been also made that the load voltage, okay, is V9. It's a lot of assumption and so on. I know that sometimes the student also is actually confused with which parameters need to be used, right? But in test or in final exam, you can always ask the lecturers or the invigilator to seek the clarification whether the voltage it is line or phase. Okay, it should be mentioned in the questions. So actually, this one I think this question is not complete. So but please be noted that for this exercise, for this course, and for this topic, the load voltage given is always referred as a V line. Okay, and also for your information, uh, what is the voltage type? What is the voltage at your socket? For example, from your home socket, which is 240 volt RMS. Is it a V phase or V line? 240 volt RMS from your socket. Is it V phase or V line? Okay, anyone? V line. Okay. So yes, you are correct. 240 volt is your V line. So that's why, um, yeah, sometimes all the power lecturers, they they know that automatically the load voltage is always referred to the V line because all their actually applications, their research, their works is always know they know that the V load is always V line. Okay, so if you don't remember, so please you can remember it by asking yourself what is the 240 volt. Is it line or volt? Is line or the phase? So 240 volt is actually V line. Okay, so 10 kilovolt is your V line actually. Okay, so we know that for the short line, okay, so this one is your IR and this one is your IS. Okay, IS is equal to IR. Okay, so and you know that I, which is IS, and IR is actually, and in this case, I line is your I phase. So you can use this one, 3 V phase I phase cos theta, or you can also use square root 3 V line I line cos theta. You can use both. Okay, but since the voltage is given, in a V line. Okay, so and I line is also your I phase. I think it's better to use this. Okay, so meaning that you have 500 kilowatt is equal to square root 3 multiply 10K multiply with I line multiply with your power factor 0.9. So your I line is 500 over square root 3 over 10K over 0.9. So your I line is around 32 ampere. So this is I line. And what is your I phase? Okay. So usually, so your I phase is also 32 ampere. Okay. And what about the angle? What is your theta I? Okay. So VR. So actually the angle you can get from the power factor. So 0.9 in cos inverse 0.9, the angle in that theta V at the receiving end minus theta V theta I at the receiving end is around negative 25 point, sorry, this one positive because lagging. Sorry, this one should be negative. Okay, so we know that power factor is the difference between voltage and also the current. So theta V minus theta I at the receiving end is equal to negative 25.84. Why negative? Because it is a lagging power factor. Okay. Should be, sorry. When it is lagging, should be positive. Theta V minus theta I. Yes, should be positive. Okay. Theta V minus theta I, if this is lagging, should be positive. Okay. So since we know that VR is your reference, so this one will become zero angle. So meaning that your theta R is actually negative 25.84. So your current is actually I line, which is your I phase, is 32 with an angle of negative 25.84. So if you draw the phasor, so this is your VR with an angle of 0. So this is your IR, which is negative 25.84. Okay. So if you want to know the power factor, so cos theta V minus theta I, which is 0 minus 25.84, so you should get positive 25.84. Okay, cos 25, which is 0.9. Okay, so please be noted that for the lagging power factor, the angle difference should be positive. Okay, so this is for the lagging. Okay. How can a negative angle at the end? How can IP? IP is actually your eyeface. Is a negative angle at the end. Because here, yeah, I saw this one. Okay, because the cost one questions from you. So actually, how I get negative because 0.9 lagging mean that theta v minus theta I, okay, at the receiving end, okay, 0.9 lagging meaning that positive. Positive cos inverse 0.9 is 25.84 degrees. Okay, and we know that theta v is actually our reference. So the angle is 0. So there was 0 angle minus theta IR is equal to positive 25.84. So that's why I have my theta IR, the angle of the current at the receiving end is actually negative 25.84 degrees. So meaning that my IR is 32 ampere with an angle of theta IR, which is negative 25.84 degrees. Okay. So lagging power factor, the different voltage and current is must be always positive. But for the leading, theta V minus theta I should be negative. Okay. Because lagging, you should know the relationship of the phasor. So this is your VR. The current is always lagging. Okay. So meaning that V theta V, this one theta I, should be always positive. Theta V minus theta I always positive. Okay. For the leading power factor, this is your VR. This is your I, which is theta I. So leading meaning that theta V, the current is leading the current. So meaning that the theta is much higher than, has a higher value than the theta V. So that's why for the leading power factor, the different voltage and current angle is negative. Okay. Okay, next is calculate at the voltage at the sending end of the line. First of all, what you need to do is to get what is the Z total. First of all, Z total of the line. So it has been given to you the R, which is 0.1 ohm per kilometer, and the inductor is 0.424 millihenry per kilometer. Okay, so R is 0.1. You need to multiply with kilometer, so 30 kilometer. So you should get 0. Sorry, this one I think that just to make sure. So this one is actually uh, 3 ohm. Okay. What about XL? The next one is to get the XL. So XL is omega L multiply with the kilometer, 30 kilometer. Okay, so omega is 2 pi multiply with the frequency multiply with 0.424 multiply with 30 kilometer. So you should get 2 multiply with pi multiply with 50 multiply with 0.424 multiply with 30. Is it correct? Oh, sorry, 4 to 4 millihenry. Milli. Okay. Should be milli. Yeah. Milli. So over 1000. So 3.99 or maybe 4. J4 here. So your Z total is 3 plus J4 ohm. So that is your Z total. Okay. And by using the equation, we know that Vs is equal to VR plus IR multiplied with Z total. VR. Okay. So this one is actually phase values. Okay. Because we know that Vs is this circuit is actually per phase, meaning that all the value here must be in phase value. Okay, so from this example, VR is given, but this one is line voltage. So we need to get VR in phase value. So 10 kilovolt over square root 3. Okay, square root 3. Okay, and the angle is 0. Okay, because VR phase is our reference, not VR line. Okay, VR phase is our reference. So VR phase is 10 kilovolt over square root 3 with an angle of 0. So this one is 5.77 K angle 0 multiply with IR. We have already obtained 32 ampere with angle of 25.84 negative. So 32 negative 25.84 multiply with 3 plus J4. Okay. So plus 32. So mode, we need to use mode complex. 5.77 K angle 0 plus 32 angle negative 25.84 multiplied I obtained 5.85 5.85 with an angle of negative 0.37. I don't know whether it is correct or not. Let's see the answer first. Maybe I have do something. The answer should be 5916. Yang salah. Betul lah. 34, 32, negative 25.84 multiply 3 plus 4i. Okay. plus 5.77. Okay, say I got 5.91. 5.91K with an angle of 0.7. Okay, so this is actually V phase. All are actually phase. Okay, and usually we want the voltage value in the line value. So what you need to do is actually uh, to convert it. So after you have obtained your VS phase, so your VS line is actually, you just need to multiply square root 3 with an angle of 30 degrees. Okay, multiply with your VS phase. Okay, so you should get 5.91K with an angle of 0.71 multiply with square root 3 with an angle of 30 degrees. So you should get 10.223K with an angle of 30.7. So this is your VS line. Okay, so this is the final answer. Okay, and if you cannot follow me, this is recorded. Okay, I will post it into YouTube after this. And also in this example, there is also solution for you to follow. Okay, so as you can see, this is the final answer, 10.3 with an angle of 30.7 degrees kilovolt. Okay, and there's always self-assessment questions. So you have the answer. I have the answer here, but also I will give you the solution. So, but please make sure that you do first, okay, and then check your answer or your step by referring to my solution. Okay. Okay, I think we take a break about 3 minutes before we go for the medium line representation. Okay, so take a break. So we start at my right now is 9:28. Start at 9:30, I think. Okay, 9:30 a.m. So 2 minutes. Take a break. Maybe you want to go to toilet and so on. Okay, so Assalamualaikum. So we meet again. So we start now for the medium line presentation. And just to remind you that this medium line representation will be in your second test. Okay. So so the medium length, okay, not is actually around between. Oh, sorry. Previously, I think inside my notes, I said about the length. Okay. Sorry. So meaning that this one is less than 80 kilometer, and this one for the medium length is actually around 80 to 240. So the long line representation is higher than 240 kilometer. Okay. So please do the correction. So medium length is around if the line length is around 80 to 240 kilometers. But unlike the short line, for this medium line representation, there are two model, which is you can model or you can represent this line in two types, whether by using representation of a T circuit or representation of pi circuit. So what is T circuit and pi circuit? So this is actually the T circuit. Okay, it represent it has the shape of T. Okay, so same with the short line. So you have a sending voltage and the sending current, receiving voltage and also receiving current. But right now, as you can see, we have several components here, meaning that IS is no longer equal to IR. Okay, because you can see we have this capacitance here, which is Y, which is Y is equal to Y is actually the admittance. Okay, JBC. So what is your BC? What is BC? BC is actually what? So I want you to find out what is BC. Okay, it's actually the admittance. So and then this is the impedance by divided by 2. So okay, and then meaning that this is all actually must be in a phase value, and okay, phase value. And as noted earlier, for the receiving end, the connection is actually Y connection. Okay, Y connection, meaning that I line is I phase, but B line is actually square root B phase with an angle of 30 degrees. Okay, but this is the per phase equivalent circuit. So this is all must be in phase value. Okay, and then what is next is actually you need to represent this relationship in a matrix form. Vs Is is equal to, we have the parameters, ABCD parameters, VR and IR. Okay, so meaning that you need to know the relationship between A plus B IR, and another one is the relationship between IS and VR, and also, sorry, this one is C, this one D. Okay, so to get this, the first relationship, okay, you can always refer to this circuit, where from here I can see that my Vs is equals to okay, the voltage drop, which is Is multiplied with Z over 2, plus the voltage drop here, which is IR multiplied with Z over 2 plus VR. Okay, so I have now my Vs as I is equal to IR and VR. So we have this function, but Is you need to actually transform into another function. Okay, so actually this one, you need to know what is Is. Okay, Is is actually this form. That is your Is. and then you rearrange and you will get your parameters. A is equal to 1 plus zy over 2 and B is equal to this parameters value. Okay. And the same case goes also to get what is the relationship between IS with VR and IR. So you can always refer to the circuit to obtain this relationship. Finally, the T circuit representation is matrix is this one. Okay, but please don't be afraid that I have been informed that this matrix will be given in your test and also your final exam. So do not memorize. Okay, but I want you to do homework. What is Y? Okay, Y is equal to JBC. So please do your homework on to obtain what is actually Y. Y is actually the admittance. Okay, so this is the T circuit representation. And the next representation or the next model to represent the medium length line is what we call the pi circuit representation. So instead of Z is actually divide into half. Okay, but what for the pi, what we do is actually the admittance is divided to half. Okay, so as you can see, the shape is actually in a pi shape right now. Pi shape here. Okay, rather than T shape. So that's why we call this one as a pi circuit representation. Okay, so same thing, you need to get the relationship between VS, okay, VS, the matrix here, VS, IS, and also this is your matrix form A, B, C, D, VR, and also IR from here. Okay, so you can always refer to this circuit to obtain the parameter here. Okay, so this one is for the first equations. You have this parameter A and you have parameter B, and the second equation, which is IS, VR, and IR. So you have parameter C and also D. Finally, this is the matrix form for the pi representation. Okay. Okay, so actually for the medium length, so we have pi and also t. So actually the representation is different, but the answer will be similar. Okay, the final answer, for example, to get what is your voltage sending values and so on, is actually the same. You will have the same answer. The only difference is actually how we actually represent the line, either to use T and also pi. Okay, and okay, so this one is actually quite similar with a short line representation on in terms of its calculation and so on. And I think we finish our class with this example. I think you can go through this example first because it's quite long, okay? But there is also solution and also what is actually admittance and it's all about. So I think you can refer to the example here, and I think in my notes I also that I have already shared with you, I've also have given or highlight some important point before you proceed with this example. Okay, so the voltage given here 30 kilovolt is actually your V line. Please be noted that this is a V line. Okay, so this is your VR line actually here. And the receiving end is always a Y connection, meaning that I line is I phase. And the power given here is 3-phase power. Okay, and then reference is actually VR phase. Okay, is your reference, not VR line. VR phase is your reference, meaning that meaning that from here you need to convert into VR phase first. So 30 kilovolt over square root 3, then you put 0. So this is your VR phase. Okay. And as you can see, there is a sentence here given that the conductor of the line are arranged symmetrically with distance. So please ignore this sentence. I think because this one is taken from the previous generation of this course, SKEE. So we didn't actually take into account the distance between the phase conductor. Okay. So please also ignore this one, the solution. This one you can ignore. Okay, so you start with the admittance of the line and so on. Okay, so that's why this course has no what call official textbook, because this course takes several part only from the books. Okay, so some of the book they consider a lot of another consideration in their calculation. So that's why this course has some trouble on to get what I call examples. Okay, example from another book. So this course has lack of actually example of practice. Okay, so please you can always refer to this one solution. Okay, and then so I think I leave it to you to solve this one first. Okay, so next class we will discuss if you have problems with understanding on the calculation and so on. So we will discuss in our next class. And also for our next class, we will go for the efficiency and regulation of the transmission line. Okay, so I think I leave it to you this example, so you can try do this first. So if there's any questions before we dismiss. So, okay, thank you. So I think if there is no question, then we can dismiss and we can proceed with this example calculation first. Okay? Okay. Okay, thank you very much. Assalamualaikum and have a very good day.